Okay, so today we are going to discuss about a very important aspect of application deployment, that is orchestration of the applications. Okay, now let's understand what is orchestration. So basically orchestration is what? Orchestration is nothing but there are different challenges. Let's first talk about the different challenges in deploying the applications on Dockers. Now we have already understood what are the different advantages we get if we deploy our application on container based environment. So what advantages we get? That we don't need to install anything on our local machines, right? Installation as well as the removal of the applications and their prerequisites are very simple if we deploy it on the containerized environment. And we have already discussed and we have understood the Docker part of it. So Docker allows us to deploy our applications on container based environments. Instead of deploying your applications on bare metal systems, we deploy the applications on container based environment inside the containers, right? But there is a problem with the deploying the applications on Dockers. First problem. What is the first problem? The problem, let me just mention it here. Problems in deploying applications on Dockers. First problem, that if application crashes, there is no self-healing. Self-healing means if your container crashes, let's say you have deployed the application Jenkins say inside the Docker container, and say if your container for some reason if it crashes, then your application will have a downtime. You have to manually start the container again to make your application available. That is problem one. So there is no self-healing. Second, there is no auto scaling. Auto scaling means what? Say you have started one container of the application and that container or that application is serving the requests of the users. But now if there is sudden increase in the load of the requests, so that same, like if you have only one instance of the application serving those requests, then definitely there will be a slowness. I mean, definitely the users will not get the response in time and they will have to wait until the application responds if there is a sudden increase in the traffic, right? So you do not have auto scaling. Auto scaling means you will not be having some other instance of the same application running there which will balance the load or which will take up the load of the requests coming in from the users. So there is no auto scaling there. So these are the two main problems we have. There are other problems also, but these are the main two problems, that there is no self-healing, there is no auto scaling, and no rolling updates. Rolling updates means what? Let's say you have your application running inside the container, so your users are using it. Now you have made some changes into that application and now you want to release that change to the users. Okay, so you cannot do this without having a downtime. Like if you want to release the change, so you have to first close the current applications container right? And then you have to run the new one with the new changes, right? But this process will have a downtime there. Once you will close the current application container, there would be a downtime for the users, and once you will start the new container with the new changes, then the users will be able to access that application. But in between there would surely be a downtime, right? So these are the three problems, okay, mainly which we are going to which we have if we deploy the applications on Dockers. Now, yes, Ramesh.
I have one query here. So when you meant about the rolling updates, let's say if I have version 1 of the Jenkins application, for example, and then I wanted to release version 2. So in order to release version 2, as you said, the version, whatever the container, we use, so that should be totally closed. So in between that time, in between the time of releasing the new version, the application will not be available, is what you meant? Or
yes, exactly what that is what I meant.
Okay. So generally, we will be having downtime for any of the application, right? Like suppose, let's say if we are opening any banking applications and stuff. So between some time, they will mention that, okay, our, application will not be available in so and so. So are you, referring to that type of example?
Exactly. I am referring to that type of example where they say that our system will not, or our application will not be available for, let's say, 1 hour, right?
Yes.
So where they release the new updates, right? So that downtime also we can get rid of with the help of orchestrating tool like Kubernetes.
Okay.
Right. So these are the main 3 problems Kubernetes solves actually. Right, there are other also, but when it comes to the application, these are the main 3 problems we deal with, right? That if the application crashes, so there would be a downtime unless someone go and starts the container again. If there are auto scaling is not only about adding the new instances of the application, it's also about removing the unnecessary application. Like for example, if you have, say for example, 10 people are currently using your application, so one instance of the application is sufficient to cater to all those 10 users. Now if the user count increases to 100, say, now you need one more instance or maybe 2 application instances running, so that 3 of the instances they can share the load, and your users will get the they will get the response, the fast response, or they will get the enough response there, like within a stipulated time. Now if your user count again drops back to 10, now there is no need of having 3 instances, 3 application instances running there. Only a single instance is enough. So these 2 instances, the 2 extra instances which had been started, right, they should be removed now, and there should only be 1 running instance. So this is called auto scaling. It is not only adding up the instances of the application, it is also about reducing the running instances of the application if there is no need of having those many instances running, right? So this auto scaling is also very important feature of Kubernetes. And rolling updates we just talked about. So these 3 main aspects Kubernetes it actually solves these three problems, and this is called orchestration. Orchestration is auto scaling, auto healing, auto updates. These processes, these are called as orchestration of the application, and Kubernetes provides us the orchestration. Now let's understand different terminologies of Kubernetes. Okay, terminologies. Now in case of Dockers, we have already understood about container. Every application runs inside the container. If your application has got multiple components, as we had seen in one of our example, there was a MongoDB, right, and a front end and back end. These three components were part of our application. So these three components were running inside three different containers, right? In case of Dockers, let me just draw here a simple diagram. So let's understand first the Docker deployment of an application which has three components. Okay, so this is a deployment of an application. Application has three components. First is a database, MongoDB. This is one container. Another front end. This is second component, and yet another component is backend. Right, so there are these three components. Now these three components, each of the component runs inside the container. This is how the Docker deployment is, and they communicate with each other using their container names. So MongoDB, if this front end wants to connect to the MongoDB, then it connects to this MongoDB using the container name. So this is how they communicate with each other. Now if the front end wants to connect to the back end, again it will be with the help of the container name. So this is how the communication between the two container, or between the applications running inside the two containers happen, right? Now in case of Kubernetes, our terminologies are little different. Now let's understand the same deployment. Let's understand this same deployment in Kubernetes now. Now in Kubernetes, first of all, let me just draw the deployment of the Kubernetes. Okay, this is the deployment of the Kubernetes. Now here we have a concept called pod, P-O-D. Okay, so this is one pod. Okay, this pod runs the container. So the containers are executed inside the pod. It is pod, P-O-D. Let me just mention it here. Pod. This is one pod. This pod, now one pod may run multiple containers if you wish to, but usually every pod runs a single container, but single pod may run multiple containers. There is no restriction as such that how many containers a single pod can run. Multiple containers can also be executed. So pod basically, let me just define a container now here. So this is a container. This is a container and this is a pod. Okay. this one is the pod, and this one is the container. Now our application has three components: MongoDB, front end, back end. So there would be three pods. You can run in a single pod also, you can run all these three components in three different containers. So if you, let's say, if you want to run this application using a single pod, so you can run that way also, but that is not the best way or right way. So you can have one pod and three containers. This is, say, a front end, and this is, say, a back end. So these are the three containers: MongoDB, front end, back end, and all of these three containers are running inside the pod. Okay, so you can have your application running inside a single pod in multiple containers. But there is a problem here. If you run all the three components of your application inside the single pod, there would be a problem. Problem is, if your pod goes down for some reason, if the pod goes down, then all of these three services would be unavailable for some time. Kubernetes starts a new pod. If the pod goes down, okay, crashes or something happens, then Kubernetes in place of it starts a new pod. That is the self-healing capability of the Kubernetes, which Docker doesn't have. If your application crashes, Docker doesn't start the new container on its own. You have to start. But in case of Kubernetes, if the pod goes down, Kubernetes starts a new pod after some time. But for that particular time frame, if all of the components are running on that pod which has gone down, then until Kubernetes starts the new one, all the three components of your application would be unavailable. Okay, so that's why you should not have all the components of your application running inside the single pod. Microservice architecture, if you have heard of it. Microservice means each and every component of your application, okay, should be running independently. It should be running independently, right? So in case of microservice architecture, you should not put all of the components of your application inside a single pod. Okay, you should be having multiple pods and each pod running a single component of your application, right? So let's talk about now how the actual deployment will look like. Okay, let me just, okay, now let's see the actual deployment, how it should be. So basically you should have, this is a deployment. In this, now our application has three components, right? So you should have three pods. This is pod 1, this is pod 2, and this is pod 3. Okay, each pod will run the container, one container. Each pod would be running single container, and that container would be running a particular component of the application. Okay, so this is MongoDB, This is front end. And this is back end. Okay, so these are the components. Now every pod has its own IP address. Say this pod, this particular one, has an IP address called, say 10, or let's say okay, just a minute. This has, every pod has an IP address of its own. Like this pod will have its IP address, this pod will have its IP address, and this pod also will have its own IP address. Now you should have each of the component of your application running in different pods. So if any particular pod goes down, for let's say the MongoDB crashes for some reason, so pod would be down. Now if the pod goes down, what Kubernetes will do, it will start a new pod. Okay, we will see like what are the different components of Kubernetes which does all these things and all that stuff. We will see that Kubernetes also has, this Kubernetes system basically has few components. Okay, etcd database, then controller, scheduler and all that. We will talk about them, but let's understand the basic functionality of this Kubernetes as a system. Then we will understand the different components of this system, and then we will set up the things to see the practicals. Okay, so if the particular pod goes down, say MongoDB pod goes down, Kubernetes will add a new pod. Automatically it will start a new pod. Inside that pod, same container it will start. Right? MongoDB container. And once it will start this container, it will remove this faulty container from its cluster. Okay, so this self-healing Kubernetes takes care of. This is point number 1. Every pod has got an IP address of its own. So if this particular component wants to communicate with the application running here, or with the component running here, it should know the IP address of the pod. If this particular component running here wants to communicate here, it should know the IP address of the pod. But now the problem here is that every pod, first of all, every pod has got IP address. If a particular application running in pod 1 wants to communicate with application running in pod 2, they should know the IP address of this pod. Now you would say, okay, what is the problem in that then? That's fine. But the problem is that if the pod goes down and Kubernetes starts a new one, it will get the new IP address. Okay, so let's say this front end is communicating with this MongoDB with its IP address, say 10.1.1.1. Let's say that is the IP address of it. So everything is going well. Now if the pod goes down, Kubernetes will start a new pod which has the IP address, let's say 10.1.1.2 for example. But this front end is communicating with that applications component on 10.1.1.1 IP address. Now you have to update all of your endpoints with this new IP address, isn't it? Which is not practical. If something goes down at runtime and Kubernetes starts a new one with the new IP address, then you cannot modify all the endpoints to reflect to that new IP address of the pod, right? That's why these two pods, they don't communicate directly with each other. If this pod wants to communicate with this pod, or this pod wants to communicate with this pod, they don't directly communicate with each other because of this problem. That IP address may change, right? So there is a concept called services in Kubernetes. Now what is services? Let's see. Let me draw another diagram. Maybe this time I will use paint. Okay, see. In case of Kubernetes, this is a deployment. Okay, now there are pods. So let me draw the pods. So this is one pod. This is second pod. And this is third pod. Now they want to communicate with each other. So instead of using IP address, there is a concept called services. So what is the service? So service is one more entity. Let me draw that using this. So this is a service. Okay. This is a service. Now this service, so let's say this particular pod number 2 wants to communicate with this pod number 1. So the communication will not be direct. It would be to service first. Just a minute. Let me just draw this. Yeah. So this would be to service first. And from service the communication would be to the pod. Okay, same thing here. If this pod number 3 wants to communicate, so it will communicate to the service, and from that service the communication would be to the pod. Now what is the advantage of this particular communication? So instead of going pod to pod, wherein there could be IP address change if the pod goes down. Okay, so this pod number 2 wants to communicate with pod number 1, and if they communicate, let's say, directly. So the problem is, if the pod goes down and Kubernetes starts a new pod in place of it, that pod, the new one, will have the new IP address, obviously, right? So then this pod number 2, if the IP address of the pod number 1 changes, it will no longer be able to communicate with it, right? Here, in case of this technique, this second point, like this particular service, what is the job of service here? So the communication will not be anytime communication will not be a direct one. It would be through service. So this pod, when it will communicate to service first, and then from service the communication would be sent to pod. Now for this pod, it only need to know the IP address of this service. It doesn't need to know the IP address of the pod. So service IP address doesn't change at all. Okay. What changes is the IP address of the pod. If any pod goes down and the new one starts, then there is a chance of the IP address change. But in case of service, there is no chance of IP address being changed there, right? So this pod, if the pod number 2 wants to communicate with pod number 1, it will first communicate to service, and then service will forward that communication to pod. Now even if this pod goes down, the pod 1, and some new pod starts, still this pod 2, which is trying to communicate or which wants to communicate, it is not communicating to the pod directly, right? So even if there is any change into the IP address of it, it doesn't matter to this pod which is initiating the communication, because this pod is communicating with the service, and then service is forwarding that request to the required pod. So even if the pod goes down and new one starts, still this pod 2 will continue to communicate with the service, and this service now, instead of forwarding that request to the old one, it will forward that request to the new one. But for this communication initiator, it doesn't matter to it, like even if there is any new pod being started because of some problem with the old one, so this communication, the communicator doesn't have any effect of this particular thing which had taken place, right? Similarly here, if the pod number 3 wants to communicate, even the pod number 3 wants to communicate with pod number 1, still that communication would be through service. So this will be referring to this service, and then service will be sending that request to the pod, right? This is how the communication between the two components or two applications running in different pods take place. No direct communication, that is point number 1. Communication from one pod to another would be through service. So the first communication would be to service, and then service would be forwarding that request to the pod, right? And if self-healing is, if the pod goes down, a new pod would be started, that would be connected to the service. Again, the old one would be removed, and all the traffic or all the connections, communication coming to this service would be transferred to the newly started pod. But there is no reference. Remember, this is very important point. If there was a direct communication, there would have been a reference of the pod which you want to communicate to. But here there is no reference of the pod you are communicating to. The reference is always of the service, and service is taking care of forwarding that request to the pod. So even if something goes down, this service only needs to update itself, but there is no reference of this with the pod which is initiating a communication or which is sending the request. This is a very important aspect which we need to understand. Service, then this is a pod, right? Any questions so far, Ramesh?
I think I'm good. So I have understood the concept, but understanding more about services or pods, I think it will be in the upcoming sessions. But as a concept, I think I have understood it.
Correct. So see, there are few concepts which we need to understand. That is, what is pod, what is service, then what is container, that we have already understood about. So the pod runs the container actually, and container runs the application. Simple as that. So there is no change in the concept of container here. Container concept is the same one which we have already discussed in case of Dockers. So there is no change here. Okay, only the thing is pod. Now there is a concept called node, N-O-D-E, node. Now what is node? Node is basically a machine on which you run your pods and in turn your containers. So this outer square, this is node, a machine on which all these things run. Okay, so in case of Dockers, we call it as a Docker Docker host, where we have the Docker running. On that we have the containers running. Inside the containers we have the applications running, right? In case of Kubernetes, the machine which runs your deployment is called as node. So this is node. Then node runs the pods runs the container, and container runs the application. Okay, this is the terminology. Please understand the terminologies first, because unless you understand the terminologies, you won't be able to understand the thing. So let me just put it here. This is node. Let me just increase the font. Okay, just a second. This is node, this is pod, this is container, okay, let me just take it inside. This is container and this is service. Okay, so node is a machine on which your deployment executes. A pod is pod is an entity which runs the container, and container runs your application, and basically a service which facilitates the communication between the two pods, right? This is how it will look like, or these are the terminologies. Let me just save this.